All of you write saturated hydrocarbons. Two statements you have to write. The first statement is a saturated hydrocarbon generally burns in air. Saturated hydrocarbons means bracket you should write. Who is a saturated hydrocarbon? Sai? Alkanes.
Alkane.
Alkanes generally burn in air. Generally burn in air with a blue and non-sooty flame. Bracket you write clear flame, or we can say clean flame. That is the good word. Clean flame. Clean flame means what, guys? No soot particles, no smokes and all. That is what clean flame will say. Okay. Next one. Next one. Unsaturated hydrocarbons. Who is the unsaturated hydrocarbons? Alkenes or alkynes?
Alkane.
Alkynes. 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 They will burn with a sooty flame. Unsaturated hydrocarbons, that gives a sooty flame with a yellow color. Yellow and sooty flame. That is what you have to remember. Yellow and sooty flame. Or you can say yellow flame with lots of black smoke. That is what you have to write. Yellow flame with lots of black smoke. Do you understand, everybody? So, in activity 4.3, they are saying the third point. You are all having NCERT book. Activity 4.3, third point, read all of you. Third point, everybody. Third point in activity 4.3. Read it. Read loudly, nothing will happen. None of you are having book?
Place a metal plate above the flame. Is there a deposition on the plate in case of any of the compounds?
Yes, definitely. So what is the compounds? We'll find it. So definitely the sooty deposit on the metal plate in the activity 4.3. That is what, when we are burning, I'm not writing Rajagavan, just listen. So when we are burning, all of you should remember, if it is a unsaturated hydrocarbon, if it is a unsaturated, can you see the screen now? If it is unsaturated hydrocarbon, understanding? Now, definitely it will deposit the sooty, understanding? That is what a black substance, a sooty smoke on the metal plate. So if you rub with the finger, you will get a powder-like substance. That is what you can get it. Can you able to see now my Word document, everybody? This needle is, I think, almost over that writing pad. That is why it is getting like some rough sound. That is why I'm not writing much. This needles it's become very rough. So you might be noticed. Can you able to observe, everybody? So definitely we'll observe the deposition of this sooty flame on the metal plate. So remember, whenever these unsaturated hydrocarbons will burn, definitely they will produce less heat energy compared to the saturated hydrocarbons, and they also burns with a yellow flame and by producing huge amount of black smoke. That is the one thing. Or else, sir, if I will burn even saturated hydrocarbons, can you able to see the screen now, please? The spot. If I'll take even saturated hydrocarbon, always two kinds of combustion will be there. Anybody can tell me what is the type of combustion? Is it right, Kevin? Kevin is asking one question, guys. Observe everybody. Sir, saturated hydrocarbons produces clean flame due to the presence of less amount of carbon. Right, sir? Or wrong? Is asking. Right. Because of less percentage of carbon only. But now saturated also will produce a sooty flame. Anybody can tell me what cases it is? All of you. It will also produce a black substance. Yes, anybody? Very good. That is what? Incomplete combustion. Incomplete combustion. The most important reaction, all of you should remember, as saturated hydrocarbons basically produces non-sooty flame. That is what we will say blue or a clean flame. Understanding? A clean flame with any kind of sooty particles, that is what we'll say complete combustion. Understand all of you? Complete combustion will take place. They will produce a blue and clean flame. But if it is undergoes limiting supply of air, that is what we used to say. What is the limiting supply of air? Insufficient supply of air. Limiting supply of air, then we used to call it as incomplete combustion. So by that time, the saturated hydrocarbons also will give what flame, guys? They will give the sooty flame. That is what you have to remember. Understand all of you? So basically unsaturated hydrocarbons, they undergo complete combustion or incomplete combustion, doesn't matter. Always they'll produce a sooty smoke with a yellow flame. But here saturated hydrocarbons, if it is sufficient supply of oxygen, blue and clear flame will form, no soot particles. If it is incomplete combustion, definitely it will also produces yellow flame, as well as it will be producing a sooty flame only. That is the reason you can see your gas burner, the holes are not properly open, because of, like, when we are cooking, if it will be turns into like something overflow and all, the holes are blocked properly, like it is not properly open, then it will start producing dubuk, 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 like that sound will come. Have you noticed it, guys? Or else gas is almost over, then your gas stove will produces the sound. Have you noticed it? Some tap sound will come. Then if you hit with that burner holes, if you clean, then again the flame will come as like a blue flame before. Have you noticed it, everybody? Yes? Please respond. So you might be checking, that is what it is. Okay, now one more is asking one question. Elmukil. Sir, saturated hydrocarbons like will produces clean flame. Yes, Elmukil, but efficiency is less. Heat energy, calorific value is less. So now Elmukil is asking, sir, saturated hydrocarbons like C10H22, is it the clean flame? Yes, all the saturated hydrocarbons undergoes complete combustion will produces clean flame only. But the question what I am saying, can you understanding? Is if the number of carbon compounds is less among efficient, that then calorific value is more. That is what I am saying. Do you understand? All of you?
Yes, sir.
That is so. If I take C10H22, now C4H10, now CH4, all are saturated hydrocarbons only. But in this, among these three, who is the best one? Is CH4. That is what I want to convey you. So that is you should remember. Okay. So that point also you should write if you want. It is very important only. Let it be write that point. Right. The saturated hydrocarbons is saturated hydrocarbons generally burns in air with blue and non-sooty flame. Because the percentage of carbon in the percentage of carbon in the saturated hydrocarbons is comparatively low, which gets oxidized completely by the oxygen present in air. Suppose if I am not providing limited, if I'll produce only if I'll supply the less amount of oxygen, or else there is no proper supply of air, then saturated hydrocarbons also burns with what flame?
Sooty flame.
They also burns with a sooty flame, means lot of black smoke they'll produce. That is what you have to remember. Is it okay, everybody? So for example, in our home, you can check it. that is what it will happen. Our gas stove, basically it will be, maybe it will burn with LPG, but if the sufficient supply of oxygen is not there, then even though it is a saturated hydrocarbon, it will burn with a black smoke only. So that is what you have to remember. So you might be notice a gas stove or kerosene stove used in our home, which will be having inlet, that is what I said, burner for air, so that sufficient oxygen rich mixture is burned, then it will give you a clean blue flame. But if you'll observe, all of you, if it is insufficient supply of oxygen, then it will start producing a black flame or sooty flame. But if we take unsaturated hydrocarbons, you might be notice, all of you, how many of you know cooking on firewood or cooking on kerosene and cooking on gas? Have you noticed the difference? Can anybody tell me what is the real life difference you notice? I want to know from everybody. You might be definitely notice it. Suppose I have taken a one bowl, I burn in the firewood. Suppose Mr. Sai is cooking with the firewood, and another one is cooking with the kerosene, and another one is cooking with the gas stove. So what is the difference you can find, guys? Anyone can change. Same bowl I am giving you. What is the difference you might be noticing?
Sir, in firewood and kerosene, black will deposit, sir.
That is the main thing I want answer from everybody. So if you'll cook it with the help of gas, you can see the bottom surface of the container never turns into black. Have you noticed it, everybody? Yes, please. All of you? Nobody, no response. But if I am burning with the firewood, you might be noticed within a days the bottom surface will turns into a complete black and the thickness also increases. Have you noticed it or not? Even in the kerosene also, we can notice the bottom surface of the container turns into black slowly when we are keep on using for cooking. Is it true or not? Have you noticed it, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Given. So now here, that is also very important. So all of you observe, this is the most important one. The bottoms of these cooking vessels getting blackened because the air holes are blocked and fuel is getting wasted. All of you should remember, if there is no proper air supply, means air holes blocked, not complete combustion is taking place and fuel is getting wasted simply. So by this time, that fuels such as like coal and petroleum have some amount of nitrogen and sulfur in them. So whenever these air holes are blocked, these coal and petroleum products having nitrogen and as well as sulfur, so these undergo the oxidation reaction and they will form the oxides of nitrogen and sulfur, which are the major pollutants in the environment. So that is what the bottom surface of vessels will turns into black. So all of you should remember, the air holes are blocked and fuel is getting wasted. Slowly the cooking vessels will turns, the bottom surface will turns into blackens also. And all of you remember, the bottom of cooking utensils is getting blackened only because of when we are using a low calorific value fuels also. So whenever low calorific value fuels will, why low calorific value fuels I am saying, anybody can tell? Because they are having what? Yellow flame with the sooty particles, so that they will produce what? The black sooty, which will turns into deposit on the surface of the container. Or unsaturated hydrocarbons also, which will undergo not burning completely. All of you should remember, they are not burning completely, then they will start producing the smoke. That smoke also causes to deposit on the bottom surface of the container. So that is why all the unsaturated hydrocarbons, if you take alkenes, alkynes, everything, including like kerosene, everything you might be see, they'll burn with what flame? Everybody? They'll burn with what flame? Unsaturated hydrocarbons, all of you.
Sooty flame.
Sooty flame, yellow sooty flame producing black smoke. So, for example, if we'll take what is the alkene and alkyne, the first family member of alkene and alkyne? Yes, please.
Ethene, ethane.
Ethane.
Ethine. So, ethene and ethane is the first family members of alkene and alkyne, which will burn in air with a sooty flame. So, that is why all the unsaturated hydrocarbons burns with a sooty flame because of the percentage of carbon in unsaturated hydrocarbons is higher or low, guys? Higher or low? Higher, comparatively higher than that of alkanes. So that is why which they will never get oxidized completely in the oxygen of air. So that is the reason it will always leads incomplete combustion. So as we know in air, what is the percentage of oxygen, guys? Oxygen percentage. All of you. What is the percentage of oxygen?
21.
21 percentage. Understand? But this oxygen is insufficient for the complete combustion of unsaturated hydrocarbons because of only one reason. Because of they are having high carbon percentage or low carbon percentage. High carbon percentage. Understanding? So that is the only difference between them. So because of high carbon percentage, they are unable to get sufficient supply of oxygen. So that is why they are not producing the blue flame. They are producing the yellow and sooty flame. Okay. For example, if I will produce pure oxygen, then what will happen, guys? Unsaturated hydrocarbons also. Anybody can guess what will happen? All of you. If I will produce pure oxygen, what will happen? 100%. Suppose if normal air, it is producing only 21% oxygen, so that it is not sufficient to complete combustion. Suppose unsaturated hydrocarbon, try to understand. If I am supplying the pure oxygen, what will happen? All of you. Unsaturated hydrocarbon with a 100% like pure oxygen, so that it will go under complete combustion or incomplete combustion. Anybody?
Sir, complete combustion, but
Yes, please.
yellow flame.
Yellow flame, that is what I am saying. So when I will supply with the air, all of you remember, unsaturated hydrocarbon with air contains only 21% of oxygen, so that comparatively it is low, and because high carbon percentage is present, it is not sufficient to make it complete combustion, producing a blue flame and non-sooty flame. But if I will supply the pure oxygen, then they will also burn, understanding, completely producing a blue flame without any smoke at all. That is what you have to understand. If I am presenting under the pure oxygen, then unsaturated hydrocarbons also will undergo complete combustion and they'll produce the blue flame without any smoke at all. Do you understand, everybody? Please respond. Are you clear? No, Elmukil. Now, Elmukil is asking one question. Sir, if unsaturated hydrocarbons is burnt in the presence of H2, will it produce clean flame? Hydrogen is a combustible substance, not supporter of combustion. Do you understand, Elmukil? Oxygen is not a combustible substance. It is a supporter of combustion. So, if you want to take place the combustion reaction, you need to supporter of combustion, not combustible substance. Do you understand what I'm saying? That is what. So, all of you remember, if unsaturated hydrocarbon is provided with the pure oxygen, then it will also undergoes completely producing a blue flame without any smoke at all. So to prove that, we'll do the one activity also. Tomorrow's class we'll study and we will make it, which we are using in our daily life. Now, all of you should underline the page number 60, 70. You'll be having one thing in your NCRT. All of you open that and learn that. That is the most important one, that how the bottom surface is becoming black. So all of you remember, a mixture is not burned into give a clean blue flame. So if you'll observe the bottoms of cooking vessels getting blackened only in the sense of the air holes are blocked and fuel is getting wasted. So that is the situation we people will get. A bottom surface of the containers becomes black. That is why by burning of firewood and kerosene, they are unsaturated hydrocarbons, means higher percentage of carbon is present, so that oxygen supply is not sufficient for the complete combustion. So that is why they will burn with a sooty flame, and that sooty flame will turn the bottom of the surface into what? Getting blackened. Okay, and also the fuels such as coal and petroleum, they have some amount of nitrogen and sulfur in them. So, and these combustion results in formation of oxides of sulfur and nitrogen, which are major pollutants in the environment. What is the major pollutants of that? Anybody? What is the major pollutant? Nitrogen. What is the greenhouse gases? Nitrogen monoxide and sulfur dioxide. They are the major pollutants of environment, because sulfur dioxide during the rainy time, it will cause us to form the acid. What is that acid called as? Anybody?
Sulfurous acid.
Sulfurous acid or sulfuric acid, and it will cause us to acid rains. And nitrogen, nitric acid, and also it is one of the most dangerous greenhouse gas. That is why the burning of coal and petroleum also leads to, that is what fossil fuels we can say. We'll study that next. So burning of fossil fuels always leads to environmental pollution, because of they contains, along with the hydrocarbons, another thing is nitrogen and sulfur also. So these will react with oxygen and they'll produce us harmful substances like nitrogen monoxide, nitrogen dioxide, and sulfur dioxide, etc. So that is what you have to remember it. Now, Kevin is asking one question. Again, he's asking the same thing. So why do unsaturated hydrocarbons gives yellow and sooty flame? So now, what is the reason behind? All of you should say. What is the reason behind, Amma? Kevin is asking that question. Because of, what is the reason, guys? Why do unsaturated hydrocarbons gives yellow and sooty flame? What is the reason behind, guys?
Hydrocarbon.
Unsaturated hydrocarbons having comparatively high carbon or less carbon percentage? Everybody.
High carbon.
High carbon.
High carbon.
Carbon.
Yes. Kevin, be very careful. Unsaturated hydrocarbons having higher carbon percentage, but Kevin is saying low carbon. Very good. Saturated hydrocarbons having less amount of carbon, so that it is sufficient to, understanding, burn completely in the air, and it will produce the blue flame and non-sooty flame. But unsaturated hydrocarbons, they're having comparatively high carbon percentage, so that the oxygen which is present in air, just 21%, it is not sufficient to undergo complete combustion. So it will produce us always a yellow and sooty flame. Is it okay, Kevin, now?
Okay, sir.
Now, unsaturated hydrocarbons, if I will undergo pure supply of oxygen, not air, pure oxygen, then they also will produce us complete combustion with blue flame and non-sooty flame. Are you clear, everyone? These are the three statements you should remember. So this is what is our today's class. Then tomorrow we'll study what is the disadvantages of this incomplete combustion of fuels, and later we'll go to the second type of reaction. What is the second type of reaction, everyone?
Substitution.
Substitution. Okay, so let it be with this. I will stop the today's class. We'll continue from here, and later some important carbon compounds we have to study. We'll try to finish maximum within this week, and this weekend we'll complete this exercise and we'll study. So this is the most important one. So please kindly study very carefully. Whatever it is, line to line, you have to analyze and make it. Okay. Thank you all of you. We'll meet in tomorrow's class.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.
Thank you.